Dear students, in the statistics today we are going to see about statistical inference. Let us see some basic terminologies today. I am Dr. C. Sudhakar with you. Let us understand what is the basic terminologies in statistics. Particularly in statistical inference, we are going to see some terms. The very first term is called population. Population means it includes all of the information connected to a set of business. You have to take all the data. So that is a definition. Sample. Sample is a set of observations collected from a large collection of population. Let us explain this by using an example. Suppose that we want to know the average height of 12-year-old American boys. It is not possible to measure all the 12-year-old boys in America, but we could measure a sample of boys living in a particular school hostel. So in this example, the boys who are 12 years old in America is the population. All the people who are in the age of 12 is a population. The sample is we have taken a particular school. From that particular school we have taken the boys only. So boys who are studying or living in the particular school hostel are called samples. So population is a very big data which contains all the informations. Let us go back to the definition and we see that a population includes all of the information connected to a set of business. Sample is a set of observation collected from a large collection of population. If you want to say what is the 12 years old American boy's height, the set of all people who are in the age of 12 in America, the boys is the population. But we are taking a sample boys living in a particular school hostel. Particular school hostel may be having 100 or 200 boys. So that 100 or 200 boys is called the sample. So sample is taken from the population, a small quantity. Statistical inference, what is the meaning for that? Statistical inference is the act of generalizing from a sample to the population with calculated degree of certainty. Statistical inference means it is a prediction. Okay, for example, if you want to buy a sweet, we can go to the shop and we can take small piece of the sweet and we can taste it. So if the taste is good, we think that the whole basket of sweet or whole box of sweet will be having same taste. So we can generalize that idea and we are buying that. So therefore, the same way in the data set also, we take some decision on the sample and we are generalizing it to the population. This is the meaning for statistical inference. Now, the sample was divided into two. First one is called large sample. The sample size n, if it is greater than 30, it is known as large sample. So 30 is a rough boundary which was accepted by all the statisticians across the world to decide whether the sample is a small sample or large sample. For a large sample, the sampling distribution of statistics are normal. Okay, so that is a normal sample. We take the test as Z test. Small sample means by this time you would have guessed that any sample which is less than 30 is considered as a small sample. So based on the size of the sample, the testing and the inferences will be different. That we are going to see it in the later videos. In any hypothesis, it will be converted into two. Hypothesis means what is the statement we are interested to test. For example, if you are going to the sweet shop and if you want to know that the sweet is good or not, the sweet is good, that is the hypothesis. Okay, so the statement what we are interested to test is the hypothesis. The hypothesis was divided into two. First one is called the null hypothesis. Every hypothesis test contains a set of two opposite statements or hypotheses about a population parameter. So hypothesis will be framed on the population parameters. The first hypothesis is called null hypothesis H naught. The null hypothesis always states that the population parameter is equal to the claim value or the sample parameters. Okay, that means we take the sample and we are taking some decisions on that, so there is no difference between the population parameter and the sample parameter, so we take it as null hypothesis. Alternate means which is the opposite of that, so the name itself suggests that it is the opposite of that. It can be true or it can be false. Okay, so we say that if the alternate hypothesis is accepted, in the case of null hypothesis is rejected. So let us see how to frame the null hypothesis and alternate hypothesis in any statistical testing. So always the null hypothesis says that nothing new is happening, nothing change happened, the previous result is the same as it was before, or the group has the same average in the case of height. In general, you assume that people's claim are true until proven otherwise. So the question becomes, can you prove otherwise? In other words, can you show sufficient evidence to reject H0? This is how we can frame a null hypothesis. So the null hypothesis always says that there is no change, nothing new is happening. Okay, the previous result is same, or the group have the same average. Okay, so like that, a null hypothesis says that there is no change happening, whereas the alternate hypothesis says that it is coming down or it's coming up, it is not equal. Okay, so these are the three different ways we can say the other side of the null hypothesis. So assume that alternate hypothesis says that there is no change, null hypothesis says that there is no change, alternate hypothesis says that there is a change. So in any statistical inferences there are errors possible. We classify the errors into two types. Two types of errors can happen. First type is, it's called a type 1 error. Type 1 error will occur when we accept H1 or reject H0 but H0 is true. So actually we should accept the H0 but mistakenly we have rejected H0, so that is a mistake. That error is called a type 1 error. So type 2 error is, on the other hand, it was accepted, H0 was accepted, but practically H0 is not correct. So we fail to reject H0 when it is not true. So let us put a tabular form that will be easy for us. What are the two types of errors? First type error is H0 is rejected but we accept H0. Okay, so H0 is rejected but H0 is true. That is a type 1 error. Type 2 error is H0 is accepted by the statistical test but actually it is not true, it is false. So this is type 2 error for us. So the type the errors is called the level of significance, to which level we can allow the errors. So it is based on the data and it is based on the study. Level of significance or level of error allowed will change. It can change from 1% to 10% or 25%, like that it will change. Now, in which way we can test the hypothesis? Testing the hypothesis having two tails. It is based on the nature of the alternate hypothesis. In a research hypothesis statement, if the following words are there, then it will give you a clue for us to choose the alternate hypothesis. Okay, testing hypothesis, check for some particular words and we can finalize that whether it is a one-tailed test or two-tailed test. So suppose if the research hypothesis states that is it possible to decide it is more than, is it possible to decide it is the average marks of the student is less than, is it possible to guess the average weight of a student is greater than 50 kgs, is it possible to guess the weight of a laptop is less than 5 kgs. So test the hypothesis. After making advertisement campaign, the result is improved. Test a hypothesis after taking a medicine, the effect of the disease is decreased. Test the hypothesis after taking a medicine or taking a finding the medicine, the spread of virus is reduced. Like that, if some words are given, the researcher is interested to know any one of the side, or sometimes it is possible to have any one of the side only. In that cases you can say it is a one-tailed test. If there is no such word, which means the researcher wants to know that whether the population parameter claim is true or false, it is equal or not equal. If it is coming not equal, then we can say it is a two-tailed test. Okay, if there is no clue or idea on the alternate hypothesis, both ways are possible. It is higher is also possible, lower is also possible, greater is also possible, lesser is also possible, improvement is also possible, not improvement is also possible, means we can say that it is a two-tailed test. Okay, so very carefully by reading the statements of the question, we have to decide the alternate hypothesis. Let us take a sample question and we'll see how to test the H0, H1 and finding the test. A random sample of heights of 20 students in a class 5 gave a mean of 68 inches with standard deviation of 3 inches. Oman statistics data shows that mean height of a student in class 5 in Oman is 70 inches under the assumption that heights are normally distributed. Identify the null and alternate hypothesis and decide it whether it is a one-tailed test or a two-tailed test. Okay, so in this question, what is the data given is Oman statistics says that a student who is studying in class 5, the average height is 70 inches. So this is the overall statistics. So but actually if you want to test this statistics, what a researcher is doing is he is taking a sample of 20 students in class 5. So go to a school and take the class 5 and take some 20 students. You can measure their heights and find the mean value of the heights. So it is giving 68 and the standard deviation is 3. So these three data are observational data. We go and do it on one-to-one basis and we find the data. Now our aim is to test whether this Oman statistics is accurate or not. Okay, so Oman statistics is accurate or not. So always the null hypothesis is going to be it is correct. Therefore we can take the average height of students in class 5 in Oman is 70 inches. The average is represented by this letter mu. population mean is represented by this letter mu. This is population mean equal to 70. So this is from the Oman statistics. So what is the other way possible? It can be higher or lesser. So both ways are possible. Okay, we cannot say always the students are greater than 70 only. Okay, so it is not, we can get in both the ways result. So the alternate hypothesis is mu is not equal to 70. It can be higher or lower. Since both sides are possible, this is going to be a two-tailed test. Okay, that means higher or lower, both are possible. This is how in any question, first we should choose what is a null hypothesis, what is the alternate hypothesis, and based on that, what is the nature of the tail test. Let us take one more question. An environment specialist collects a liter of water from 25 different locations along the bank of a stream. He measures the amount of dissolved oxygen in each specimen. The mean oxygen level is 4.62 with the standard deviation of 0.92. A water purifying company claims that the mean level of oxygen in the water is 5 mg. Research has been done to determine whether the mean oxygen level is less than 5 mg with alpha is equal to 0.001. So write the null hypothesis, alternate hypothesis, and decide whether it is a one-tail or two-tail test. So what are the data given here? The company claims that the mean level of oxygen in the water is 5 mg. So this is the company's claim. I told you the null hypothesis is always going to be, it is same. Therefore, mu is equal to 5, okay, 5 mg. What is the alternate hypothesis? The researcher has to determine whether the mean oxygen level is less than 5 mg. He wants to check whether it is less than 5 mg. So we take alternate is less than 5. So since the alternate is coming in only one side, we can say it is a one-tail test. Alpha is given in the question 0.001. Some questions they will give the alpha, some questions they will not give the alpha. In case if they don't give alpha, by default we can take it as 5%, that is 0.05. Alpha level is allowable level of errors. So it depends on the nature of the data. Sometimes we will allow 5% error, sometimes we can allow 1% error. Some test which is related to the human life, for example, when you are testing a vaccine, the error percentage allowed is 1% or even lesser than that, 0.5%, that means 0.005. Okay, so here it is related to the water content, so which is consumable by the human, so they take the test alpha is equal to 0.001. So whenever a test is related to human lives or any sensitive information, alpha level will be very low. By default, any economical decisions will have 5%, or any business decisions can have 5 to 10% error. Okay, this is how we can choose the error. So H0 is this, HA, so it is given level is less than 5 mg. This gives a clue for us that alternate hypothesis is less than 5. Usually the researcher's claim will be taken as an alternate hypothesis. So in this case it is a one-tail test. Hope you enjoyed learning mathematics with me, and this is the statistical inference basic video. In the coming videos we'll post on how to do the inferences and what are the tests available to us and how to use them effectively in our research projects. Okay, keep watching. Signing off, Dr. C. Sudhakar.